Hey guys, so here's another example FRQ number 2. So FRQ2 is calculator active, so you're allowed to use your calculator. And you'll see that it's similar to the previous ones that we've done before. Okay, so it gives us a table, and then now let's read the words. It says the table gives the number of people standing in line for a political campaign event. When the entry gate opens at 6 a.m., which is t equals 0, so actually up here where it says 0, I'm just going to label it in case I need it. This is 6 a.m. There are 176 people in line. By 10 a.m., which is t equals 4, there are 833 people in line. And in 3 hours after that, which is t equals 7, so 3 hours later, that would be 1 p.m., there are 632 people still in the line to enter the event. The number of people in line can be modeled by a quadratic function, p, given by that model, where p of t represents the number of people in line t hours after the entry gates have opened. So part A, use the given data to write 3 equations, so 3 equations, that can be used to find the values for constants a, b, and c in the expression. So the 3 equations we're going to get from this 3 sets of data. So of course t is hours, and then the number of people, this is p of t. They told me that down here. So we're just going to plug these numbers in, and that's how we get our 3 equations. So for part A1, we would have 176 equals a times 0 squared plus b times 0 plus c. So I followed this format. Okay, now I need to do the same thing with the next point. So 833 equals a times 4 squared plus b times 4 plus c. And then now that last data point, 632 equals a times 7 squared plus b times 7 plus c. Okay, so those are my 3 equations. If it makes you feel better, and honestly, I kind of want to do this, I would simplify. So this first equation, anything with a 0 is going to cancel out. So really all that's left is 176 equals c. The second equation, I know that 4 squared is 16. So I'm going to simplify this to 833 equals 16a plus 4b plus c. And then on the third one, I know that 7 squared is 49. Okay, so those are my 3 equations. Then for part 2, it just wants me to actually find the values. So we already have c. So A, B, C. We already have that c is 176 from that first equation. If you want to, you can try plugging in here and then solving this as a 2-variable system. But we're allowed a calculator, so I'm going to do that. So I do have my Desmos testing one pulled up. But in this case, because it's quadratic and because it's 3 equations, I think it might be easier to use my Inspire. So I'm going to pull that up. Let's make this look like a real calculator. Okay, so there's my Inspire. So what I want to do is I want to go to my system solver. So I'm going to go to regular calculator, menu, 3, and then you see where it says solve system of linear equations. So 2. I have 3 equations, but this time I want to solve for ABC. So you can change this to what you need. Press OK. And then let's type in our equations. I have 176 equals C. I have 833 equals 16A plus 4B plus C. And then I have 632 equals 49A plus 7B plus C. Okay, so those are my answers. I'm going to click on this and then do Control Enter so it can give me decimal approximations, because that is what the instruction said to do, decimal. So all I did was Control Enter. Sorry, I'm pulling everything up that I shouldn't be. There we go. those are my values. So I'm gonna write that down. And you want to round at least to 3 decimal places, if not more. Okay, now where did this go? Okay, so A is negative 33.0357 and B is 296.393 and C is 176 like we said it was going to be. Okay, then for part B1, use the given data to find the average rate of change in the number of people waiting in line from t equals 4 to t equals 7. Express your answer as a decimal approximation and show your computations. Okay, so for this one, rate of change is basically just slope. So I need to find the slope between t equals 4 and t equals 7. So I know that means that 7 and 4 are going to be down here. But what is the value of y when t equals 7? So I have 632. And then when t equals 4, 833. So that needs to go on top. 632 minus 833. So I'm actually going to continue using my Inspire for this one. You can use Desmos if you like. But 632 minus 833 over 7 minus 4. So I just get negative 67. This is actually just a whole number. Okay, now for part 2. Use the average rate of change found in part 1 to estimate the number of people in line at time equals 6 hours. Show the computations that lead to your answer. Okay, so rate of change has to be a linear equation. So first I'm thinking y equals mx plus b. But hold on. We have a rate of change, so we have an m. But for y-intercept, usually you're looking for a point that's 0, a number, which technically we do have a point. But I found the average rate of change between these two. And see how this one doesn't fit in with the pattern? So I can't really use that as my y-intercept for now. So what we're going to do is we're still going to do a linear equation, but we're going to use a different format. So hopefully this looks familiar to you guys. Y minus y1 equals m parentheses x minus x1. So m is our rate of change, but x1, y1, that's just one of the points. It doesn't matter which one you use. I'm going to use this one here. So 4, 833. Okay, so let's fill that in. This would be y minus 833 equals, we said our rate of change was negative 67, x minus 4. And then this 833, I'm going to move it over to the other side. So I still have parentheses, but now I'm going to have a plus 833 at the end. Now to estimate for 6 hours, let's just plug in a 6 right there. Six minus 4 plus 833. And that gets me 699. Okay, but what was this estimating? It was estimating number of people in line. So 699 people in line. Okay, and then now the third part. The average rates of change found in 1 can be used to estimate the number of people in line for t hours for t is greater than 7. Explain why the estimates using the average rate of change differ from the values given by model P. Use your explanation, or your explanation should include characteristics from the rate of change and reference the graph of P. Okay, so model P is this one up here. And remember, we found numbers for A, B, and C, so we can go ahead and plug those in. So what I'm going to do is now I'm going to go to the graph, and I'm going to do model T. So basically this one, but plugging in numbers. So A is this. but then it has an x squared, plus b, which is this number, 296.393x, and then plus c, which is 176. So all I see are these two lines here. I promise it's a parabola. It's just that these are pretty big numbers. If I'm looking at my t values, the biggest number here is 7. I want to go a little bit past that. And then plus, this is a pretty big number as well. So I'm going to go to Menu, Window Zoom, and Window Settings. For x, I'm only going to go from 0, let's say, to 12. And then for y, let's go 0 to, so you see how this is 300 right here? Let's go 500 and see if it works or not. Honestly, we're just guessing. So that wasn't big enough. So back to my window. Let's go up to 800. Still not big enough. Let's go up to 1,000. Or you know what? I want to play it safe. Let's go 1,500. So now it was a little bit too much, but that's okay. So there's my parabola. Now I want to graph the line that we came up with. So it's not how we're used to, but it is still an equation. So I'm going to type that in. So tab -67 x minus 4 plus 833. And there's my line. So right here is where I want, and I'll even show you those intersections. I promise that one of them is going to be at 4, one of them is going to be at 7. So I'm just going to do this. So see that one at 4, and then this one at 7. But this is really the one that's more important, the 7. Okay, so I want to know what happens after that. So if you look at this, the red line is my straight line. It's above the blue curve. So if I were to estimate the number of people in line using that line, it's always going to be a higher estimate than what the blue one is doing, than what the quadratic is doing. So a line always has constant rate of change. So this one's -67. It's constantly changing by, like, we're losing 67 people per hour, basically. But with a quadratic, it increases for some time, but once it hits the max, and it's going to start going down. And yes, it's decreasing, but it's decreasing at a faster rate than the red one is. The red one is constant. The blue one, it's going to keep decreasing at a decreasing rate. Okay, so that's what they want us to explain. So the estimates using the average rate of change differ from the values given by model P. So this is going to take me some space, so I'm actually just going to work it out on a different sheet here. So this was B and then 3. The estimates using average rate of change will be greater than the numbers found using model P of T for T is greater than 7. So I'm saying how they differ. So it says differ, but now I need to explain why. So that line, we actually call it a secant line. So the secant line is decreasing at a constant rate of 67. But the quadratic model is concave down, and therefore decreases at a decreasing rate. Okay, and then our last part, part C, the political campaign rally is scheduled from 12 p.m. to 5 p.m. Explain how the range of values in function P should be limited by the context of the problem. Okay, so domain and range, so this is model P, by the way, which when we graphed it, we saw that it's a parabola. Okay, so at T equals 0, there were already 176 people in line. So I'm gonna, actually let's pull up our graph. And I'm gonna erase this for now. Okay, so at T equals 0, which is basically X equals 0, that's the y-intercept. So I'm gonna do graph trace and show you. So when you're on something important, a little yellow flag will come up. So there's my y-intercept, 176 people. So that's kind of like right there. And then we went over it a while ago, but I'm gonna go back to it. I want that maximum value. So at 449, comma, 841. And then I want to go all the way up to T equals 12 because that's where they're telling me to go up to. So as long as this little cursor is there, you can type in any number you want. So there's my 12, and it'll automatically go to that number. So this right here is basically 0. It would be nice to know what that x-intercept is right there. So let's find out. So 953 and 1.116 times 10 to the negative 10 is basically 0. Okay, so this is what my graph looks like for right now. Now think about what this represents. The first number is time and the second number is people. So for domain here, that's the one that's time. I can't be there for negative hours, right? So I would have to start at 0. And then they're telling me that they're gonna go all the way until 5 p.m. So I can go up to 12 because they're telling me that 5 p.m. goes with time 12. Then for range, this is the one that's people. Okay, so it's kind of the same thing. You can't have negative people, so we would assume that we're going to start at 0. So I could have exactly 0 people. But out of all the people in the world, they can't all show up to this rally. So 7 billion people in the world. This is why it was important to find that maximum. So according to this model, the maximum number of people in line is 841. So I would have to stop there. So they're specifically asking me explain how the range values of function P should be limited. So I would write the range of P should be limited to 0 to 841 because the max Minimum number of people in line was 841. Okay, and then that is it for this one.